So here's a mini project. So our mini project is super resolution using GANs. So it's basically generative adversarial networks. It's a cutting-edge deep learning model designed to upscale low scale images into high resolution images. So the images like X-ray image or space image can be converted into high quality image using our project. So it's useful in major situations, and we are going to see that what are the algorithms and what are the library files and the codes we are going to use to convert the low scale images into high resolution images. So in many industries there are need to enhance the quality of resolution images and videos, especially when high resolution versions are unavailable. Traditional methods in image upscaling often result in blurry, distorted visuals with the loss of important details. This limits the effectiveness of an applications in medical imaging, video streaming, security surveillance, and scientific research, where clarity and detail are crucial. The challenge is to develop a method that can produce high quality resolution images and with realistic details and textures. So basically purpose of this project is to develop and implement an enhanced super resolution adversarial network to upscale low resolution image into high resolution image photorealistic image. By leveraging advanced deep learning techniques, Esrgan aims to overcome the limitations of traditional upscaling methods, preserving fine details and textures and enhancing image quality for applications like healthcare, media, security and gaming purposes. So it can be very useful in that domain, and it improves the image quality and sharpness, preserve important details and textures in the image, and minimize visual artifacts often introduced by traditional upscaling methods. So I think the project aims to set a new standard for image super resolution using deep learning techniques. So these are the methodologies proposed in our project. So first the data collection and preprocessing, and then second is network architecture, and the third is training process, and the fourth is model evaluation, and the next is model tuning, and the sixth one is testing and validation, and the seventh one is post processing and development. So by developing our model we can achieve high quality image upscaling, improved image clarity, artifact reduction, real-time image and video enhancement, wider application and content restoration, and better user experience. So when our project GAN is super image resolution using adversarial networks techniques upscale the image, integrating adversarial and reversal loss of high resolution detail and artifact free results. So the advantages are high resolution quality delivers sharp details, images and minimal artifacts and realistic details, and gives extra textures and features reduced. See, so our project has a slight drawback in the scope of the project, because it's the beginning of the if it's the beginning of this project, so it can be a little risk and it is a complex model to develop, and enhance models for a real-time image and video upscaling in streaming and interactive media is a challenging thing. High quality super resolution Esrgan produces image with much finer details and sharper textures compared to traditional super resolution models. It leverages perceptual loss to ensure that the generated images are not only high in pixel quality but also visually appealing, which improves the overall experience of the user. So it can be developed in the future, because future research could focus on optimizing Esrgan for real-time application, particularly in the fields like video streaming and interactive media, where fast processing in this situation. Lightweight models, developing more lightweight versions of Esrgan that consume fewer resources while maintaining high quality output, would broaden its adaptability. So we can expect that the project focus on implementation of enhanced super resolution universal networks to upscale low resolution image into high resolution photorealistic image, to develop and apply this process for improving image quality by preserving fine detail, enhancing textures and minimizing visual artifacts, to demonstrate the application of ESRGAN in various industries including media, healthcare, security and gaming, and scientific research. Data collection and pre-processing are the key for the development of low resolution image into high resolution image to train our model, utilizing the residual and residual dense block for better feature extraction and texture representation. So high quality image upscaling can be achieved improving the image quality and sharpness texture quality. Demonstrating real world applications of this model feels like medical imaging, video enhancement and security surveillance and gaming. The project has the potential to set a new benchmark in image super resolution by delivering sharper and clearer images that can significantly improve the user experience across various domains. Broader research and development can further refine ESRGAN to make it more efficient for real-time applications and expand its use in more specialized fields such as scientific imaging and space exploration. So yes, our survey. So from the research, photorealistic single image super resolution using generative adversarial networks. It is based on GAN super resolution method. So adversarial loss, pressure loss, and content loss are the features used in here. And the major domain is image processing, and the major advantage is the high quality image detailed with reduced artifacts, and the major disadvantage is it is very complex to train and it is more often used in the future to develop more efficient model to reduce consumptional load and improve training times. So the super resolution using the generative adversarial networks, it is based on the residual dense block and adversarial loss and perspective loss. Its major domain is image super resolution, where the advantage is it produces a sharper and more realistic image, and the disadvantage is it is very risk to train the model and it can come under overfitting. Focus on optimizing the architecture for real-time applications. It is very complex model to train and we need a lot of data set to train this model, and here we use the DV2K dataset that is available in Kaggle to train this model, and we also take the data collected across the internet to develop this model. And our next research is machine learning for super resolution. So it is based on CNN based image super resolution, and its features are convolution layer, perspective loss and feature maps. So its domain is medical imaging, video games and media, and it has advantages of improving textures and features automatically on video games, and disadvantages. It requires a large data set and it's conditional wide demanding. Develop lightweight models for broader applications like real-time video and media processing. So here is our conclusion. The project on image enhancement using ESRGAN successfully demonstrates the potential of deep learning models to transform low resolution image into high resolution image. So by leveraging advanced techniques such as generative adversarial networks and residual dense block architecture, the ESRGAN model is able to overcome the limitations of traditional upscaling methods, which is often used in many situations, and it results in blurry and distorted images. Through the implementation of this model, the project achieved significant improvements in image clarity, sharpness, texture preservation, making it highly suitable for application in various fields including media, medical image and security and gaming. The model's ability to reduce visual artifacts and enhance details has broad implications for industries that require high resolution visuals for analysis, recognition and entertainment purpose. While the project has achieved its goal, future work could be more on optimizing the model for real-time applications and further reducing its complexity with continued advancements, and this model could become the critical tool for enhancing image quality in numbers, professional and everyday scenarios. In conclusion, this project highlights the powerful capabilities of deep learning and super resolution image techniques in addressing the growing demand for high resolution image across the various of sectors, setting a new standard for image enhancement technology. So